Alright, so how do we multiply and divide radicals? Well, we're going to assume that the indexes are the same for all of these examples. You can technically multiply and divide radicals with different indexes, but we'll discuss how this works later on. There's a rule we'll be looking into, and that is that if we had some term to the bth root to the 8th power, that's actually equal to x to the a over b. And because of that, we can convert all radicals into an exponent, which would actually allow us to multiply and divide them. But for now, we're not doing that. We'll actually be looking at that in a couple of lessons. So let's assume for now that all of our indexes are the same. So in this case, the indexes are 2's. To multiply radicals, we actually multiply the coefficients, so that's negative 18. And we multiply our radicands, so that is radical 49 r to the 5th. Now we can simplify the radical. Negative 18. 49 becomes 7. And radical 5 becomes, again, we divide how many out from our index. So our index is 2, so there are 2 groups of r that we could take out of there, with 1 r left over inside the radicand. Okay, so 2 of these 4, there were 2 groups of 2, so that gave us r squared. So our final result is 56 plus 70 is negative 56 plus 70 is negative 126 r squared radical r. Okay, so in the briefest way possible, multiply the coefficients and multiply the radicands, then simplify. Let's look at a few more examples. In this case, we actually have the distributive property occurring. The same thing happens. So we're actually going to be multiplying radical 3 by 5. So the coefficient here is 1, and the coefficient of here is 5, so that's 5. The radical here is radical 3, and the lack of radical is actually the same thing as saying I have radical 1 here. So that's radical 3. Okay? And 1 here. So same thing here. There's no coefficient, so it can be assumed to be a 1. 1 times 1 is 1. And radical 3 times radical 3 is radical 9. So let's simplify radical 9, and we'll get 5 radical 3 plus 3. Alright, so you can distribute and combine terms if possible, but in this case there were no terms to combine. Let's look at another example. Alright, in this case we actually do have a coefficient here, so that's going to change things slightly. Again, if we have no radical, it's like having a radical 1, and if there's no coefficient, it's like having a coefficient of 1. Okay, keep in mind that radical 1 is 1, so 1 times 2 is 2, so this does work. Let's distribute. Negative 3 times 2 is negative 6. Radical 3 times radical 1 is radical 3. Distribute it further. Negative 3 times 1 is negative 3. And radical 6 times radical 3 is radical 18. I wrote that 8 really badly. Let's fix that. Alright, so this doesn't simplify, but this will. This has a perfect square factor of 9. So that'll become negative 6 radical 3 minus 3 times 3 radical 2, which is radical 6 radical 3, negative 6 times radical 3 minus 9 radical 2. And since these are unlike terms, we cannot combine them. Alright, one more example of multiplication, then we'll look a bit at division. Alright, so here we actually have 2 binomials, which actually have radical expressions. So we can use FOIL, just as we do normally. So radical negative 2 times 5 is negative 10. That's our first terms. Now we multiply negative 2 times radical 5, which is positive. 2 negatives make a positive. 2 radical 5. Again, if that's not clear, coefficient here is 1, the radical here is 1. Now we multiply negative 3 by 5, which is negative 15 radical 5. Again, the radical here is radical 1. And so that was this. Now we can multiply negative 3 radical 5 by radical 5, and we'll get positive 3 radical 25. And that can be simplified to just 5, which will be simplified to just 15. Alright, so it's negative 10 plus 2 radical 5 minus 15 radical 5. And now we can combine like terms. The 10 and the 15 become positive 5, and the 2 radical 5 and the negative 15 radical 5 become negative 13 radical 5. And that simplifies as much as possible. So the basic rules are that if you can multiply the coefficients and the radicands when multiplying radicals. You already know the rules for adding and subtracting them, so those proceed as normal. And yeah, you stop when you can't do it any further. And operations such as distribution and expansion work also as normal. So let's turn our attention over to division, where things work also pretty similarly. Alright, so this is actually a division of a cubic root. So one interesting rule, I mean it was kind of implied before that if we had some coefficient times some radical times some other coefficient times a radical, we would multiply the coefficients and multiply the radicals. I made a small typo here. But the same rule applies for division. So if we had radical a over b divided by radical c over radical d, we would get ac and radical b over c. And the important point here is that we can actually separate these into their own radicals. So that is the cubic root of a to the 6th over b to the 9th, and the cubic root of negative 64. Okay, and the question that sometimes gets asked is, should you separate them? And the answer is, it depends. In this case, it seems to make more sense. The cubic root of a to the 6th is a squared. The cubic root of b to the 9th, I wrote that 9 really poorly. The cubic root of b to the 9th is b to the 3rd. And from a previous video, I recall that the cubic root of negative 64 is negative 4. We can check that real briefly, because that is the cubic root of negative 4 times negative 4. Cubic root of, again, negative 4 times negative 4 times negative 4. 3 negative 4s means that the cubic root is negative 4. So that is fully simplified the way it is here. Alright, now we're going to talk about rationalizing the denominator another time in the next video. So let's move on to one last example that involves division. Here we actually have two radicals that are separated. In this case, it might actually make more sense to put them together versus take them apart. Alright, so we have 108 x to the 5th over y to the 8th, I mean with y to the 8th, over 6 x times y to the 5th. Alright, 6 goes into 108 how many times? It goes into 100 once, leaving over 48, and it'll go into 48 8 times, I believe, because 12 will go in there 4 times, so 6 can go in there 12 times. No, 8 times. So this goes in here 18 times, so that's 18. This is all inside the radical. X to the 5th divided by x to the 1st is x to the 4th. Y to the 8th divided by y to the 5th is y to the third. And now we can simplify this radical. X to the fourth becomes x squared when it comes out. Y to the third becomes y when it comes out, leaving a y inside with the 18. Alright, because two groups of 2 come out, and one group of 2 comes out here, leaving a remainder of 1. Now to simplify this radical. So that's x squared y times radical 9 times radical 2y, which becomes 3. So our simplified radical is 3 x squared y times radical 2y. Alright, other examples are similar, and we'll be looking at them in class. Alright, so that kind of covers how to multiply and divide radicals. So you saw that in some cases it makes more sense to put them back inside the radical, into a joint radical, so you can divide them. Whereas in other cases, it actually made more sense to take them into their own separate radicals, because then they were easier to take to simplify. We saw that you can expand polynomials the same way, whether they're variable terms or radical terms. We saw we could use the distributive property in this case as well, and we also saw how to simply multiply radicals. Alright, have a nice day.